Walk into any garden center in America right now and look at the fertilizer aisle. Count the bottles. Microbial inoculant, soil probiotic, biostimulant complex, mycorrhizal blend. The prices start at $15 and go up to $60 for a bottle the size of a coffee thermos. The packaging looks pharmaceutical, scientific names in small print, certification stamps, a photograph of a microscope. You have probably bought at least one of these, maybe several. You mixed them into your watering can and waited to see what happened. Maybe you noticed a difference, maybe you did not. Either way, you paid for it. And next season, when the bottle was empty, you went back and paid again. Here is what the label never told you. The organisms inside that bottle were alive in the forest floor 100 meters from where you grew up. They have been alive there for hundreds of millions of years. Japanese farmers figured out how to collect them, multiply them to 10 times the concentration of any commercial product, and feed them to their crops using nothing more than a 5-gallon bucket, 1 pound of potatoes, a handful of forest soil, and 5 minutes of their time. The total material cost is under $2. The resulting brew produces 6 different plant hormones simultaneously and doubles itself every 48 hours. The $4.5 billion plant growth regulator industry has spent decades making sure that sentence sounds impossible to you. It is not impossible. It is biology. By the end of this video, you will have the exact recipe, the science of why it works, and a clear understanding of why this method spent 60 years trapped behind a language barrier, while English-speaking gardeners were paying $60 a bottle for a fraction of what a bucket could produce for free. What healthy soil actually is. Soil is not dirt. Healthy soil is a living ecosystem. 1 teaspoon of healthy forest soil contains more microorganisms than there are people on Earth. These bacteria, fungi, and microbes are not passengers in the soil. They are the engine of it. They break down organic matter into plant-available nutrients. They produce hormones that control how plants grow. They protect roots from pathogens. They build the physical structure that allows soil to hold water and air simultaneously. Without them, soil is just crushed rock. And crushed rock, no matter how many synthetic nutrients you pour into it, does not grow food the way living soil does. The Western agricultural model figured this out and then did something extraordinary. It built an entire industry around replacing soil biology with chemistry. Instead of feeding the microorganisms that produce plant hormones naturally, it figured out how to synthesize those hormones in a laboratory, package them in a bottle, and sell them back to the farmers and gardeners whose soil had been depleted by the chemicals sold in the previous generation of bottles. It is a perfect commercial loop. Deplete the biology, sell the replacement. Deplete the replacement. Sell a better replacement. Japanese farmers saw this loop clearly. They stepped off it. The farmer who refused it. The story begins in the mountains of rural Japan in the 1960s, in a small agricultural community where a farmer named Hiroshi Tanaka had been watching the soil change around him. Synthetic fertilizers were being promoted as the modern way to farm. Yields rose in the first few seasons. Then the soil that had fed the same families for 12 generations began to feel different, harder, less alive. Crops that had grown without intervention for centuries began to need more and more chemical input just to produce a normal harvest. Hiroshi refused to follow. He walked into the cedar forest above his farm and paid attention. The soil under the leaf litter was dark, loose, threaded with white fungal growth. It smelled alive in a way his farm soil no longer did. No one had ever fertilized this forest, yet it had been producing living biomass continuously for centuries, building its own fertility from nothing but rain, fallen leaves, and the invisible activity of the organisms beneath the surface. He spent years asking one question. If the forest could feed itself for free and indefinitely, why could a farm not do the same? The method he developed spread across Japan, then across Asia, and in the last decade into agricultural communities across the English-speaking world. It is built on one central insight. The fertility of a forest is not in its soil chemistry. It is in its microbial population. Collect that population, multiply it, return it to your growing soil. The soil begins, over time, to behave like a forest floor. The science behind the bucket. The organisms that dominate healthy forest soil and multiply inside a properly made microbial brew have been studied intensively for 50 years. Bacillus, Pseudomonas, Azospirillum, Serratia, Pseudomonas. These are not exotic organisms. They live in every healthy soil on Earth. What makes them remarkable is what they produce as a normal byproduct of their metabolism. These bacteria manufacture plant hormones. Specifically, they produce indole-3-acetic acid, which is the master auxin controlling root growth and architecture. They produce cytokinins, responsible for cell division and shoot multiplication. They produce gibberellins, which control stem elongation and seed germination. They produce ACC deaminase, an enzyme that breaks down ethylene and protects plants from stress. And here is the part almost nobody outside specialist microbiology knows. Some of these soil bacteria also produce compounds with brassinosteroid-like activity. Brassinosteroids are the sixth class of plant hormones identified by USDA researchers in 1979 after processing 500 pounds of rapeseed pollen to extract 4 milligrams of pure compound. They control cell elongation, photosynthesis, fruit yield, and resistance to virtually every form of biological and environmental stress. The USDA spent decades and considerable resources figuring out what they were. The soil bacteria in every healthy forest had been producing them for hundreds of millions of years. When you brew this bucket correctly, you produce all 6 classes of plant hormones simultaneously in a living biologically active form for under $2 per batch. There is no commercial product that does this. Not because the science does not allow it, because the self-replicating biology that makes the brew effective makes it commercially impossible to bottle and ship. The industry sells you dead or dormant individual strains, freeze-dried to powder, reanimated imperfectly in your soil. For $40. The recipe? 5 minutes of actual work. Then the biology takes over for 72 hours. The bucket, standard 5-gallon plastic from any hardware store, not metal. Metal interferes with microbial activity and corrodes in the slightly acidic fermentation environment. The water, 4 gallons non-chlorinated. This is not optional. Chlorine kills the bacteria before they establish. If you have only chlorinated tap water, leave it uncovered in direct sun for 24 hours. Rainwater is ideal. Well water and filtered water both work. The potatoes, 1 pound of plain white potatoes, skin on, cut into chunks and boil in half a gallon of water for 20 to 30 minutes until soft. The starch is the carbohydrate fuel the microbial population will multiply on. The boiling water becomes a starch-rich broth that goes into the bucket with the potato solids. The salt, 2 tablespoons of unrefined sea salt. Not table salt, not iodized, sea salt or rock salt with trace minerals still present. It regulates osmotic pressure, provides minerals the bacteria need, and at this concentration, selectively favors beneficial species over harmful ones. The forest soil, 1 to 2 cups of leaf mold soil from undisturbed forest. Push aside the top layer of fallen leaves. Dig 2 to 4 inches into the dark, crumbly, fungal threaded soil beneath. That handful contains the entire microbial community you are about to multiply. If forest soil is unavailable, use the richest, oldest compost you have, or worm castings from an established bin. Assembly takes 5 minutes. Place the boiled potato solids in a piece of cheesecloth tied shut. Place the forest soil in a second piece of cheesecloth tied shut. Hang both pouches submerged in the 4 gallons of non-chlorinated water in the bucket. Add sea salt. Stir, cover loosely to exclude insects, but allow gas to escape. Do not seal airtight. Place in shade between 60 and 85 degrees Fahrenheit. Within 24 hours, foam forms on the surface. By 48 hours, it is thick and dense. By 72 hours, the brew is ready. The visible cue is the foam. When you see a thick yeasty cap on the surface, your culture is alive and ready to use. Dilute 1 part brew to 10 parts water before any application. Apply as a soil drench around the base of plants, once every 2 to 3 weeks for routine soil health. Weekly if you are working to regenerate depleted soil. Never apply undiluted. The brew is self-perpetuating. Take half a cup of finished brew, add it to a new bucket of water, potato, and salt, skip the forest soil. The microbial population carries forward indefinitely. 1 handful of forest soil becomes an entire season of biological fertilizer for a large garden. The industry does not want you to do this math. The global biofertilizer market reached $3.7 billion in 2024 and is projected to exceed $8 billion by 2030, growing at 14% annually. The bacteria-producing hormones segment accounts for over 40% of this market. Major players include Bayer, Corteva, Valent Biosciences, and Novozymes. The margins on freeze-dried bacterial inoculants are among the highest in the agricultural input sector. A jar of standardized Bacillus subtilis selling for $25 at retail represents pennies of actual production cost. A 5-gallon bucket of living microbial brew produces 40 gallons of finished, diluted soil drench for under $2 in materials, containing not one strain but dozens of species working together in ways that single-strain commercial products cannot replicate. In comparative trials, diverse mixed culture brews have repeatedly outperformed single-strain commercial inoculants in root architecture, chlorophyll content, biomass, and yield. The cumulative body of supporting research now exceeds 10,000 peer-reviewed papers. This is mainstream agricultural microbiology. What remains fringe is the suggestion that a gardener could produce the same biology at home for the cost of a potato. That suggestion is treated as radical not because the science contradicts it. It is treated as radical because it is commercially inconvenient. An industry worth $3.7 billion depends on the perception that soil biology is too complex to cultivate at home. That perception is wrong. Japanese farmers have known it was wrong for 60 years. Limitations. This brew is not a replacement for compost, organic matter, or basic mineral inputs in severely depleted soils. Microorganisms need carbon to feed on. If your soil is compacted and lifeless, start with compost and mulch. The brew accelerates a living soil system. It cannot build one from nothing. The brew is temperature sensitive. Below 60 degrees Fahrenheit, fermentation slows dramatically. In freezing temperatures, the culture dies. Make it fresh and use it within 2 to 3 weeks. After that, the population shifts toward putrefaction and develops an unpleasant smell. Make it, use it, make more. Very young seedlings under 2 weeks old can be damaged by the acidity even when diluted. Dilute further for seedlings and observe before committing to regular application. Always use the correct salt ratio. Excessive salt kills the microbes and damages soil with repeated application. The barrier between you and this. The barrier between you and a garden that produces more food with less input every year is not money, it is not expertise, it is not access to specialist materials. It is a 5-gallon bucket, 1 pound of potatoes, 2 tablespoons of sea salt, and a handful of soil from the nearest forest floor. It is 72 hours of fermentation. It is the willingness to apply something that looks like cloudy water to your plants and watch what happens. Japanese farmers have been watching it happen for 60 years. The research literature has been documenting it for 50. The organisms responsible have been doing their work in every healthy forest on Earth for hundreds of millions of years. The garden center aisle, full of $40 bottles, is not wrong about what the organisms do. It is wrong about where you have to buy them. The forest floor knows. Now you know too.